Hello, Tracy Jones here, and we are going to cover the mathematical nomenclature that is used in machine shop. Manufacturing talks about dimensions and decimals a little different than other trades, and that's what we're going to cover here. Standard decimal numerals. If you have one place to the right of the decimal, you have tenths, 2 places is hundredths, 3 places is thousandths, and 4 places is 10,000ths of an inch. Now, all decimal numbers used in precision machining will be stated in thousandths of an inch, no matter how many decimal places there are. Okay, for example, .5 is stated as 500 thousandths, okay, or 500 over 1,000. .50, still 500 thousandths. 3 places, still 500 thousandths of an inch, and even 4 places are 100 thousandths of an inch. Now, the reason this is because of the way our tolerances work. The reasons numbers are stated like this are because of our tolerance. On the bulk of your blueprints, in one corner or the other, there will be a listing of tolerances, and they will be listed similar to what I have here. If you have one place to the right of the decimal, you will have plus or minus 30 thousandths. 2 places will be plus or minus 15. 3 places will be plus or minus 5. And 4 places will be plus or minus 1. Now, these tolerances, basically all the tolerance is, it tells you how close to the nominal size something has to be. And that's what a tolerance is. The bulk of Common Ed math teachers will tell you that trailing zeros are unimportant. They're unnecessary. In other words, any zero farthest to the right can be eliminated. Well, for us, it doesn't work that way because of our tolerances. Okay? In other words, if you were to drop the last 2 zeros in the number 500 thousandths, .500, it changes from .500, 500 thousandths, plus or minus 5, which means that the size must be, to be within tolerance, 495 thousandths to 505 thousandths, changes that to .5, which makes it plus or minus 30 thousandths, which makes the dimensions, maximum and the minimum, 470 thousandths to 530 thousandths. This would be a major mistake if you produced the part using this tolerance when this was the required tolerance. There's a big difference in there. So you got to make sure that you keep all of the trailing zeros. Now, let's talk about the 4th decimal place for a minute. The 4th decimal place, when we refer to it in mathematical references, it is 10 thousandths. In machining terms, you will hear it called a tenth, meaning that is 1/10 of 1,000ths. In other words, like I said earlier, everything we deal with is in thousandths of an inch. So a tenth would be 1/10 of 1,000ths. There again, everything's referencing to the thousandths of an inch. Now, we have if we were talking about how to refer to a number, let's take this. There again, dealing with tens. Let's take 3/16 of an inch. Okay. If you take 3/16 of an inch and you convert it into a decimal, you have 0.1875, 187 thousandths and 5 tenths. Okay. Now, that's how we talk about it. So you'd have 187 thousandths 5 tenths. Now, let's take these same numbers and let's work them as far as our tolerances go. If we had it at 0.1875, we'd have plus or minus 1,000, which would give us 0.1865 to 0.1885. That would be our tolerance zone. If we rounded to 3 places, it'd round to 0.188, be plus or minus 5 thousandths, which would be 0.1825 to 0.1925. If we rounded to 2 places, it'd be 0.19, which gives us plus or minus 15 thousandths, 0.1725 to 0.2025. Okay, so these numbers are very important. When you look at these numbers, you need to look at the number as a whole. Is it a rounded off decimal of a fraction? In this case, if we had 0.188, the actual dimension would be 0.1875. That'd be the true dimension, but it's been rounded. So you always need to look at the decimals and see, is it a true fraction? And you can look at a fraction conversion chart to see if this is the case. Always make sure that you round properly and that you make everything match up properly, or you're going to have issues with dimensions as you make calculations throughout your trade.